Chapter 3, Section 1, States of Matter. Key ideas in this section: what makes up matter, what's the difference between a solid, liquid, and gas, and what kind of energy do all particles of matter have. According to the kinetic theory of matter, matter is made of atoms and molecules. These atoms and molecules act like tiny particles that are always in motion. Following are observations of particles in motion. The higher the temperature of the substance, the faster the particles move. At the same temperature, more massive or larger particles move slower than less massive ones. And the kinetic theory helps explain differences between the three common states of matter, which are solids, liquids, and gases. We can classify matter as a solid, liquid, or gas by determining whether the shape and volume are definite or variable. Definite means that it stays the same, and variable means that it can change. Solids have a definite shape and definite volume. Liquids change their shape, but not their volume. And gases change both shape and volume. A fluid is any non-solid state of matter in which the atoms or molecules are free to move past each other, like a gas or liquid. So a lot of times we think about fluids as just being liquids, but anything that can flow. So gases and liquids are both a fluid. And then there is a fourth state of matter, which is the most common state of matter in the universe, but we don't see it here on Earth as much, and that is a plasma. Plasma is a state of matter that consists of free-moving ions and electrons. We see this in lightning, pretty much the only time we see that on Earth. So the three states of matter, you can see this cup of pop. Gas would be the particles of gas like carbon dioxide. They're moving super fast. They overcome nearly all of the attraction between them. Liquid, particles of liquid move fast enough to overcome some of the attraction between them, so they flow past each other. And then solid particles are super connected together. They do not move fast enough to overcome the attraction between them, and they vibrate in place. So what is energy's role in all this? Because these particles are always in motion, they all have kinetic energy. Energy is the ability to do work, and so temperature is a measure of the average kinetic energy of a substance. Temperature is how we measure if things are hot or cold, but specifically it measures the average kinetic energy of the particles in an object. Thermal energy is the energy of heat, and it depends upon particle speed and the number of particles in a sample. Thermal energy is the total kinetic energy of a substance's atoms. And so here are three pictures. We've got solid, liquid, and gas again. Particles in a solid, like in an ice cube, vibrate in place. They're moving slower in relation to all the other states of matter. They have the least amount of kinetic energy. The particles in ocean water, because that's a liquid, move around. They have more kinetic energy than the particles of a solid, but less than those of a gas. And then particles in a gas, like steam, move more rapidly compared to those in solids and liquids. They have the most kinetic energy.